Hello everyone. Previously we had discussed on the multi-threading and multi-processing topic, right? So today we'll be discussing on the memory management and garbage collection. So we'll be discussing on the memory management and garbage collection, right? So what does the definition part say here? Let's get into the definition part first. So Python manages memory automatically using the reference counting and a cyclic garbage collector. So what does the Python do here? Python manages memory automatically using the reference counting and a cyclic garbage collector. So it reclaims memory by tracking and removing unused objects. So again, it reclaims memory by tracking and removing unused objects. So this is it for the memory management and the garbage collector. So let's discuss some more points and then let's get into the definition part. So each object has a reference count, and when the count drops to zero, memory is freed, right? So when the count drops to zero, memory is freed. So Python also handles cyclic references. This is important. Python also handles cyclic references like mutual references using a cyclic garbage collector, right? So we developers can manually control garbage collectors using the GC module. So we will be going with the GC module. So what we can do here, developers can manually control GC or the garbage collector using the GC module. So it is rarely needed. So for the optimization purpose, or you're going with the intense optimization, right? Then related to the memory management, then you can just go with a GC module. It is rarely needed. Again, it is rarely needed. Developers can manually control GC using the GC module. Just keep this in mind. This is important. It can be handy anytime, right? So the last point, developers can normally control the GC or the garbage collector using the GC module. Just keep this in mind, right? So let's get into the example part. I'll just consider very simple example here. So I'll just go with import garbage collector GC module, nothing but GC here. So let's go with the class A. So let me go with the initialization part. This will be, so yeah, init self. This is fine. I'll just go with the self dot h here. Let me assign this one to, or let let me go with the variable b here. uh, Let me initialize this one, none. So this is fine. Next, let me go with the class B. So let me go with the class B here. This is fine. Again, one initialization part here. Def define initialization. So self, this is fine. Self dot a. Let me assign this one to, again, none. Right. So here we are done. We are done with the uh, this one. We are considering two classes here. We're done with the code almost. So let's create the cyclic references first. Let's create the cyclic reference first. So this will be a equals a. This is fine. B equals b. This is also fine. We are creating the cyclic reference. A dot b equals b, and also finally p dot a equals a, right? So you would have already guessed this one. So we are just creating the cyclic reference here. After creating the cyclic reference, let's delete the references. Means I'll just go with the del keyword, delete a as well as delete b, right? So I'll just go with the delete b as well. So after deleting the references, let's do one last thing. Let's go with the force garbage collection. Nothing but I'll just go with the sorry, did I miss something? No, right? So yeah, I'll just go with the unreachable keyword here, or the variable name. So we are going with a force garbage collection, right? So I'll just go with the gc dot collect. So gc dot collect. So this is fine. Let's print something for the this interactive purpose. So I'll just go with the print. So this one, unreachable objects collected. So this is fine. uh Let me pass unreachable variable here, nothing but unreachable keyword. So this is fine. So we are done with the code, right? So the output that we need to get here is, before getting the output, but before running the code, let me tell you one thing. So here we have considered two classes. So first we have imported the GC module, right? So first we have imported the GC, we are going with the GC module, right? So this is fine. uh, Here a and b reference each other, creating a cycle. So here this one you can clearly see here, right? So we have created class A and the class B. This is fine. We have created class A and class B. Then we are creating the cyclic reference, nothing but this one, creating the cyclic reference AABB, A dot BB, B dot A, this one A, whatever I have written. So we are creating the cyclic reference. Then we are deleting the references here, A and B, this part. And finally, we are going with the line number 26 and 27, nothing but force garbage collection, right? So A and B both reference each other, creating a cycle. A and B both reference each other, creating a cycle. Line number 18 to 21, basically, right? So another so after, sorry, after del A and del B means we are deleting, right? So this part, line number 23 and 24, after deleting A and delete this one, DLB, Python can't clean up automatically due to the cyclic reference. We have cyclic reference here, right? So after del A and del B, Python can't clean up automatically due to the cyclic reference. So we have to make use of the garbage collector dot collect, nothing but gc dot collect. We have made use of this one in the line number 26, right? So here gc dot collect, this forces garbage collector to reclaim cyclic objects, right? So this forces gc or the garbage collector to reclaim cyclic object. So basically whatever the output that we get, that shows how many reachable objects were collected. Let's see how many reachable objects were collected here. So here, this is fine. Let me give Python, let me right click, rename, let me copy the file name here, let me paste it over here, .py. So here we are getting the output, unreachable objects collected, that is 2, that is 2, right? So we are getting the correct output. Unreachable objects collected is 2, right? So we are getting the correct output. So this is it for the memory management and the garbage collection. This is it for the memory management and the garbage collection, right? So let me summarize whatever we have learned so far, right? So here, just keep these 3 points in the mind. Python uses automatic memory management with reference counting. Python uses automatic memory management with reference counting. Second point is cyclic references are handled by garbage collector. Cyclic references are handled by the garbage collector. Third one is we can use the GC module to monitor or force collection. To monitor or force collection. Right. So this is it for the memory management and garbage collection, right? So next we will be discussing on the topic advanced exception handling. For now, this is it. Thanks for watching, guys.